Hello, thank you for checking out my video today. In today's video, I'm going to talk about the memory map on an 8088 processor and the I/O map, and more exclusively for the PC. And I'll explain that more here in a minute. So, what you have, hopefully the focus doesn't keep going in and out on this, but you have a 20-bit address bus, and you have an 8-bit data bus. With the, to get that in focus there, with the 20-bit address bus, what you end up getting is 1 megabyte. So we'll just kind of draw, a lot of people do it like in a square, rectangle type deal. So up here you would have the top of your memory. So that would come out to be F, 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 F. The bottom, you're going to have 0. Now, as far as the processor is concerned, there's only a little bit of like reserved memory. So right here, right at the bottom, this is your interrupt vector table. And that is going to be 0 through 3FF. So starting at 400, or 400 in hex, is available. Now, this is just the processor. I'm not talking about a PC right now. Interrupt vector table is real simple. It's every 4 bytes is a pointer. So it would be like, say, byte 0, byte 1, byte 2, byte 3 is a pointer. And it's in reverse. So let's just say, hypothetically, real quick, we're pointing to address 7D31. Let's just go make it easy. 0000. In the pointer, it's going to be in reverse. So 0, 1, 2, 3. It's going to be 0, 0, 0, 0, 3, 1, 7, D. So that's your interrupt vector table right there. And when you call an interrupt, so every 4 bytes is the new pointer for the next interrupt. So you have a total of 0 through FF interrupts. So that part's reserved. This is as far as the processor is concerned. Now at the very top, you have a very thin slice right here of 16 bytes. This is a decimal number, 16 bytes. So basically F, 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 0 through FFFF is reserved as the boot code. Because when it boots up, the code segment and the instruction pointer, code segment will be all Fs, instruction pointer will be 0, 0, 0. So this is your boot code. So your BIOS typically sits up here. Pretty much all you have is enough room to jump out of here to somewhere else in memory. So I think they put like maybe a date and then a PC type stamp at the very end of that 16. A far jump's only 5 bytes, so you still have a little bit of room to add the date and that in there. Anyway, so as far as the PC is concerned, now we're talking PC, not just the processor. Let's kind of just make a crazy mark on here. So this would be, let's see, up to A. So this would be A0000 would be right here. This would be 640K. So on a PC, your 640K sits down here. Goes up to A0000. So if you have 512, it would end here, and then then you would have this would be 80000, and then 9's in here. So conventional memory, typically 64K at the bottom, and then this is where it becomes reserved. So most PCs, and like mine, like up here at F0000, is going to be your BIOS. Also, like I have one that's a 32K BIOS, so it's at F800, which would be up here smaller. And if not quite to scale, but E is reserved for BIOS as well. And then D is, I think your expanded memory card will sit in there, but this is all kind of reserved. B, we'll call C. So B, draw it up here on top. This is your CGA video BIOS. VGA, that's like on my project, is right here as well. I want to say monochrome might have been in this A000 part, but I'm not sure. But all you need to worry about is from here to here is reserved. So that you can't use that for code. It's reserved. BIOS is at the top, conventional memory at the bottom, minus the 0 through 3 FF. Now, with most BIOS up to 5, so 400 through 4FF is reserved for BIOS data. So really, you're starting at 500 on conventional memory. And then that starts to fill up with DOS, and that'll start to fill that up. So that's kind of your memory map on an 8088 PC. You got your interrupt vector table, BIOS data area, remaining of your 64K conventional, and then you got reserved up here. You got your VGA, CGA, video BIOS, or sorry, video memory mapped here. EMS goes up in here. And then E0, this is all BIOS stuff. Let's talk about ports real quick. So ports, they're actually addressed very similar to memory. Basically, the pin is low for memory. On an 8088, it's low, and it's high, the memory I/O pin, and it's high if it's an I/O. Other than that, the read-write, everything's the same. This sits on the 8-bit data bus. The only difference is it's a 16-bit address. So 8-bit data. Real simple here. For the PC, and this is for my PC as well. This is going to be from memory, so I might slip up here. So in hexadecimal, 00, and mine is decodes the top. Let's see, that'd be 16 through. So I don't decode the bottom 4 lines. So 000 is DMA controller. 002, 0. Keep in mind these are not decoded down. Because like this is your interrupt controller. And so like the interrupt controller's got an address 1 on it. And so then the address 1 goes on there. But the top 3 digits here are decoded. Anyway, so keep going. 0040 is your programmable interval timer. 0060 is keyboard. 0080 is the index for your DMA. Because DMA is meant for a 16-bit address. That's direct memory access, so it's dealing with memory. So it needs an index for the remaining 4 bits. Because it's designed for a 16-bit system. And that's where the index register comes in. Kind of 61 is kind of a like a settings register. It's used with, it turns the keyboard on and off. On my system, the only thing it really does is I think it just turns the keyboard on and off. It enables the channel check as well. It's kind of a read-write register, but it is kind of linked with the keyboard in a way. So that's port 61. And then that's kind of it. For a PC, that is. Now, obviously, they added on a lot more. You know, your CGA card's going to have its own ports to talk to, but I'm just talking about the system board itself. Now, on my board, I do have one additional, and this is the USB drive. And these are all hexadecimal numbers. So that's kind of the breakdown of the memory map and the I/O map. So something to note, there's some cheaper systems, or cheaper cards, I should say, that go in your card slots. They may not decode all the lines. And when they do that, they'll overlap in your I/O ports. So you'll be able to access it through like consecutive ports. You know, like say you didn't decode these lines here, then it'd be like 180, 1180, 8880, if these were not decoded. So there are some cheaper cards that didn't do that. But generally speaking, most cards do decode down quite a bit. So anyway, if you like my video, please subscribe and hit the like button, and I'll see you on the next video. Thank you for watching.